Our next example says the weight of an object varies inversely as the square of its distance from the center of the earth. So here it says weight varies inversely. So we already know it's going to be one variable when it says inversely is k divided by another variable as the square of its distance from the center of the earth. So I'll put W for weight. Now notice this time it doesn't say it varies inversely as the distance. It says it varies inversely as the square of its distance. So instead of just D, I need to put D squared, like that. Watch out for that. Sometimes it'll say square or square root instead of just a regular variable. All right, so that's our basic equation. Next it says an astronaut weighs 180 pounds at sea level, which is 4,000 miles from Earth's center. So we'll put 180 for the weight equals, we don't know what k is yet, and then we put for our distance 4,000. And notice it is d squared, so we have 4,000 squared. Working that out, we would have 180 equals k divided by, and if you do 4,000 squared, you would have 16 million, like that. So next, you multiply both sides by 16 million. So 16 million times 180. Boy, we get a really big number here. We get 288 and then, oh goodness, 1, 2, 3, 4, 5, 6, 7 zeros equals k. So we can go back and write our basic equation now that we know what k is. W equals 288, 1, 2, 3, 4, 5, 6, 7, divided by d squared. Now we'll look at the last question that says, how much does the astronaut weigh 2,000 miles above Earth's surface? The mistake that a lot of students make on this problem is plugging in 2,000 for d. But notice what d is. D isn't distance above Earth's surface. D is distance from the center of Earth. So keeping that in mind, let me do a quick amazing drawing here. Here's our Earth. Here's our astronaut. We're talking about distance from the center of the Earth. Now the distance from the center to the surface, we've already said, is 4,000. The astronaut is another 2,000 feet above the center, not feet, miles. So here, put together, that distance is a total of 6,000. So what we need to do for this problem, we're going to have W equals that whole big number we found for k divided by, not 2,000 squared, I was about to do it again myself there. The distance from the center of the Earth is 6,000. So we have 288, whatever that is, divided by 6,000 squared. So let me take that answer, divided by 6,000 squared. We end up with 80. And here, let's see, our weight is in pounds. So our weight at that height above the center of the Earth would be 80 pounds. Let's try one more example. Here it says, the bounce height of a tennis ball varies directly as the drop height. So, bounce height, capital B, varies directly as the drop height D. Without even reading the rest of the problem, I should be able to set up the basic equation. Varies directly, the directly part is key here. That's what tells us instead of k divided by whatever comes next, it's going to be k times whatever comes next. So our bounce height B varies directly as the drop height D. So there's our basic equation, B equals k times D. Then it says the bounce height is 20 inches when the ball is dropped from an initial height of 30 inches. So setting that up, we have 20 equals k times 30. Then we divide both sides by 30. Let's see, 20 over 30, I'm just going to do it as a fraction. We would have 2/3 equals k. So we can come back up here and write our equation as B equals 2/3 D. Then we look at the last sentence, find the bounce height if the drop height is 50 inches. So we're going to take 50 and plug that in for the drop height. The bounce height is 2/3 times 50. Oh, so that's going to be 100/3, which is about 33.33, and here we're dealing with inches for our units.